The first atmosphere primarily consisted of hydrogen but was lost to space early in Earth's atmosphere. The second atmosphere was produced by volcanic outgassing. The gases produced were similar to those in modern volcanoes. There was no free oxygen in this atmosphere. Greenhouse gases warmed the planet, and when the Earth started cooling, water could exist as liquid, which allowed oceans to form. Oxygen was added into the atmosphere by water molecules breaking up by ultraviolet light, which allowed the ozone layer to form and shield Earth's surface from ultraviolet. This is known as photochemical dissociation. Photosynthesis also occurred when carbon dioxide, water, and sunlight combined to provide organic compounds and oxygen. Oxygen was then consumed by chemical weathering, animal respiration, and burning of fossil fuels.
Natural selection is the process in which traits and species become either more or less common. This was part of Darwin's theory of evolution. In Darwin's process of natural selection, he explains for adaptive traits that a species needs to evolve, which are variation, inheritance, high rate of population growth, and survival of the fittest. In regards to variation, in order for it to happen, mutations must occur, which are changes in the genetic code.
One well-known prediction for life's origin is the heterotrophic hypothesis, the idea that life evolved from a primordial soup of simple inorganic chemicals that dissolved in the ocean's waters. The scientists who proposed this theory, J.B.S. Haldane and Alexander Perrin, believed amino acids originally formed while more complex organic compounds only existed later on. It's known as the heterotrophic hypothesis because it suggests organic compounds were used as an energy source by the first life forms. This hypothesis has been well supported over the years, as in 1953, Stanley Miller and Harold Urey performed experiments that showed evidence supporting this potential prognosis.
During each mass extinction event, an epidemic occurred, killing most, if not all, of a species. The first mass extinction took place at the end of the Ordovician, where 60% of all terrestrial and marine life worldwide were exterminated. The second one, 360 million years ago, in the late Devonian period, nurtured reefs turned hostile and could no longer support the animals. The third one, at the end of the Permian mass extinction, 80 to 95% of all marine species went extinct. The fourth one, the end of the Jurassic mass extinction, it claimed half of all marine invertebrates and 80% of all four-legged animals that went extinct. Lastly, the end of the Cretaceous mass extinction associated with the extinction of the dinosaurs, where almost no animals survived.